Now that the basic model is set up, I'll add to it. In this task, I'll work on geoprocessing the data for the city boundaries, roads, and water feature layers. I'll also clip the airports to Nueces County. To start again, I'll open up the graphic modeler and open my model. So I'll go to the processing menu, graphical modeler, click the open button. It'll default to the My Data folder that I set as the default. I'll select my model and open. And expand this because it's going to be adding quite a bit to it. I'll start this task by adding an input for airports. I'll double click the vector layer input and I'll call this airports LYR, shape type of point, required yes, and I'll click OK. And I'll drag this down here below the rest. I'm going to have all the inputs on the left-hand side and the geoprocessing operations going out to the right. I'll clip the airports with the Nueces County layer. So now I'm going to switch to the Algorithms tab, expand QGIS Algorithms, expand Vector Overlay, and choose Clip. The input layer is going to be the airports layer, and the clip layer is going to be the output from the algorithm 0 extract by attributes. And I'll leave the output blank so it'll just create a temporary layer. And click OK. So now I've added my second geoprocessing operation to the model. Now I'll work with the city boundaries. This is the most involved parameter because the site must be both within 3 miles of Corpus Christi, which involves a buffer operation, and beyond the Corpus City limits, which is going to involve another operation called difference. So to start with, I'll add a vector layer input for city boundaries. Switch to the Inputs tab, double click on Vector Layer, and I'll call this City Boundaries LYR. It's a polygon layer. It's required, and I'll click OK. I'll drag this down below the airports. Next, I'll need to do an extract by attribute on the city boundaries in order to extract the Corpus Christi boundary from the full layer. So I'm going to need a table field attribute. I'll call this City Boundaries ATTR. The parent layer is going to be City Boundaries, and I'll click OK. I'll drag it below the parent layer. And now I'll need another extract by attributes to extract Corpus Christi. So I'll go into Algorithms, expand Vector Selection Tools, extract by attribute. The input's going to be the city boundaries. The selection attribute will be city boundaries ATTR. The comparison will be equal. And the value is going to be Corpus Christi. And I'll leave the output blank. Click OK. So there's this extract by attribute algorithm added to the model. The next step for processing the city boundary site selection parameter is to buffer the Corpus Christi layer by 3 miles. So I'll expand Vector Geometry Tools and search for Fixed Distance Buffer. There it is. I'll double click on that. The input layer for this will be the output from algorithm 2, extract by attribute. The distance is going to be 4828.03, which is the 3-mile buffer distance in meters. All my data is in meters, so that would be the metric equivalent to the 3-mile buffer. I'll take the rest of the defaults and click OK. The last parameter detail related to the boundary of Corpus Christi is that the airport needs to be located outside the city limits. Therefore, I need to take the 3-mile buffer output and run a difference algorithm on it with the Corpus Christi output as the difference layer. This will take the buffer and erase from it the portion within the city limits, leaving a 3-mile ring around the city limits. So I'll go into the Vector Overlay Tools, double click on Difference. The input layer is going to be the output from the buffer from algorithm 3. The difference layer is going to be output from algorithm 2, and I'll leave that blank and click OK. And if you're never unsure about which outputs to choose, you can simply look at the connections between your different algorithms on the screen and make sure that's making sense. Now we'll work on the roads parameter. First, the county roads will have to be selected. Then those county roads will be buffered by 1 mile. So I'll add another vector layer input. So I'll switch to the Inputs tab, double click on Vector Layer, and this will be called Roads Layer. It's of type line. It's required, and I'll click OK. I'll drag this down below city boundaries. I'll add the table field input so we can select the county roads from the layer. This will be called roads ATTR, and the parent layer will be roads. Click OK, and I'll drag this below its parent layer. And next I'll need another extract by attribute algorithm added to the model to extract these county roads. So I'll switch to the Algorithms tab, double click on Extract by Attribute. The input layer is going to be the roads layer. The selection attribute will be the roads attribute. The comparison operator will be equal, and the value is going to be C, because remember, looking at the attribute table for this layer, the county roads were identified with a C. And I'll leave the output blank and click OK. And I've noticed sometimes in the processing modeler that the connecting lines disappear. And I've discovered that's not an issue. I'm going to save my model and close it. Expand models. Go into GS102, right click on it, and edit model. Whenever they disappear, I've noticed if you just save it and close it and reopen, that it's all there. Now I'll buffer the county roads by 1 mile. So I'll go into the algorithms, expand QGIS algorithms, go into vector geometry tools, and choose fixed distance buffer. The input layer is going to be the extract from algorithm 5. The distance will be the number of meters in 1 mile, which is 1609.34. And I will take the remainder of the defaults. And I'm not going to worry about those connecting lines for now. It is a known issue, and I know that as soon as I can save this when I'm done, reopen it, and everything will look the way it should. The last parameter to address is the distance to water features, which are going to be buffered by 1/2 mile. This is the easiest parameter to address. I just need to add a vector layer input. I'll call this water features. The shape type is line. It's required, and I'll click OK. I'll drag this down to the bottom. And now I'll need a buffer. So I'll double click on fixed distance buffer. The input layer is going to be water features. The distance is going to be 1/2 mile in meters, which is 804.67. And I'll take the remainder of the defaults and click OK. And I'll drag this over by its input feature. Now that I've put in everything, I'm going to save my model, close it, and I'm going to reopen it just to make sure it looks okay. And there we are. We have all the initial parameters developed. In the final task, I'll combine all these individual parameters into one layer representing the combination of all parameters. This will represent the acceptable area for the helipad locations. And I'll then run a clip algorithm on the airports to determine which airports fall within that acceptable area.